coming to our webinar on motion control technology. Today we're going to be discussing motion control, which is a type of automation technology that involves moving parts with the help of equipment like motors, actuators, and servos. Programmable motion controllers and software are used to implement logic operations and to acquire input and output data. Motion control is widely used in machine automation, robotics, gaming, packaging, and printing. If you have any questions at any time, please enter them into the chat box. I'm Maria Limoni, Sales Manager here at ICP DAS USA. First, we'll provide an introduction and we'll go over motion control technology, step motor systems, servo motor systems, motion control hardware, and software. Then we'll go over motion control applications. After that, Steve from our technical support department will introduce LabVIEW and PC EasyGo motion control software. ICPDAS was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICPDAS USA was launched in 2001 to support the North and South American markets. We provide free online trainings twice a month and also provide customized training classes on automation technology. We can help you to select products for applications and also provide free programming services for very small and very large projects. Motion control is an automation technology that involves controlling moving parts with equipment like motors, actuators, and servos. Programmable motion controllers and software is used to implement logic control operations for robotics, machines, and data acquisition of inputs and outputs. Software is used to move equipment to precise positions at specified times. A step motor is a DC electric motor that converts electricity into rotation. It divides a full rotation into a number of equal steps. Each pulse of electricity turns the motor one step. You can control the step motors very accurately. You can control how far it will rotate and how fast it rotates. A typical step motor system consists of the following parts. First, you need a computer or a PLC to control the system. The step motor system can be applied to applications like the raising of a machine or the advancement of a conveyor. A PC or PLC is connected to an indexer or PLC card, which sends commands to step motors and tells them what to do. Based on the number of pulses output by the PLC card, the step motor then performs the rotation and the load. A servo motor is often referred to as a rotary actuator or linear actuator, which provides precise control of the angles or linear positions of objects. It can be applied in robotics, CNC machinery, factory automation, anything that needs to move the position of an object. For example, it can be used to make a robot pick up a screwdriver by controlling a robotic arm movement. The use of a servo motor often requires a sophisticated PLC that works with it. We provide a wide selection of motion control equipment. The MP8343 is a motion programmable automation controller, combining the functionality and openness of a PC with the reliability and simplicity of a PLC. The MP8343 is designed for time-critical and deterministic operations. It's being used in factory automation, building automation, machine automation, laboratory, chemical, and environmental monitoring. IDash 8092F is a two-axis stepping pulse type servo motor control module that can be used with any of our i8000, Windcon, and Linpack type controllers. It can also be used with the MP8343 motion programmable automation controller. It has an FRnet port, so you can expand I/O with this very easily. FRnet is a two-wire type bus that we provide, and it can support up to 2.88 millisecond scan time. This IDash 8092F product, it supports two-axis linear interpolation, circular interpolation, also TS curve acceleration and deceleration. Most of the motion control functions are performed with very little load on the processor. so it can drive motors, provide the motion status, and also provide I/O status very quickly. The PISO PS400 is a 4-axis stepping pulse type servo motor that can be used with any IPC with a 5-volt PCI bus. It contains an FRnet port, which allows fast and easy remote I/O expansion. The 2-wire FRnet bus can support up to 128 digital inputs and 128 digital outputs. It has an automatic scan time with 2.88 milliseconds. This also supports the 2-axis linear interpolation, 2-axis circular interpolation, TS curve acceleration and deceleration, also synchronous actions, automatic homing, and more. ET8194H is a motion control module. It has an IDash 8094H module inside, which is a 4-axis stepping pulse type servo motor control module with an embedded CPU. It supports Modbus TCP, so it can be used with PCs, PACs, and PLCs. So that's programmable personal computers, programmable automation controllers, and also programmable logic controllers. This ET8194H, it can also be used with the Easy Move utility that it comes with, and it also comes with an API library that you can use for program development, and you can use it to configure ET8194H for rapid development of customized control applications. As you can see here in the picture, you can connect the IDash8094F module to a daughter board, DN8468, for connecting to servo motors. So our motion control applications are used in CNC machines, also many different kinds of machinery applications, robotics, and factory automation. In this application here, you can see there's an HMI, and operators can operate the machine. It's a PC running inside of this machine, and different operations can be performed by the machine, like bending tubes, and our controller, the user inputs what they want to do into the HMI, and the PLC, it talks to the PLC, which performs the different recipes and operations specified by the program. You can also communicate with other machinery over the Ethernet bus to get information back, and the status lights are turned on and off at the top of the machine based on the operations. So the Windcon was our first programmable automation controller, and it's equipped with IDash8094 4-axis motion control module, and it's connected to a daughter board. The daughter board is connected to some FRnet I/O modules for turning things on and off, and servo motors are connected to different equipment for the movement of the machine. So basically it's a motion control machine application. Steve's going to be talking to you more about the PS600 PC EasyGo type software and also LabVIEW. So let me transition over to Steve. And then while we're transitioning over to Steve, I'll go over some of our company benefits. We provide customized products and OEM capabilities. We also have low lead times of usually less than a week. We have competitive prices, and we also provide hardware and software solutions. So,
thank you, Maria. Today I'm going to show you the software application on our motion control cars. Here is one of the examples showing the status of the PS400 4-axis motion control board. This VI can control and monitor the motion of the motor when running. Each axis needs to have a VI to be shown. All the basic information will be shown on the status page, like counter, position, speed, and acceleration. Direction of the motor can also be changed here. You can see reverse and forward. This one is, we also have a software called PC EasyGo. give us an easy way to configure each axis for the PS600 6-axis motion control card with FRnet. The customer can like the PCEasyGo utility because it can simplify the process to operate and configure the motion card. We can test single motion function without any program effort. We provide visual motion card status monitoring and control motion function, and it can shorten the learning curve, which is easy for troubleshooting when integrating the whole motion system. This picture shows the fully operational mode with PS600 card installed. You can see all the target axes of the motion card as tree structure. Each axis can be configured separately and selected. This is the program installed in my computer without the PS600 card installed. It provides 4 different options. Like the first one, this is the configuration dialog. Encoder mode can configure the encoder input mode as AB phase or chloride counterchloride. On the output phase mode, the types of pulse output are classified in the 6 modes. Here, 0 to 3 is counterchloride or chloride. Dual channel mode, 4 to 7 is a pulse single channel mode, and the other is conjecture channel mode. Here. For the hardware signal settings, the polarity of the hardware signal are set in the sub-items, including hardware limit, home sensor, near home sensor, and servo motor C phase signal. For the servo input signals, it can configure feature enable, disable, and logical trigger level of the servo alarm signals here. Input signal filtering settings can allow the delay time of each input signal filter vary from 3 microseconds to like 245 microseconds. And here is the DO settings on-off switch. Next one is the basic operation page. All the motor parameters are shown here, including velocity, acceleration, jerk, etc. And you can set the driver mode here, speed profile, like T profile have a constant acceleration, deceleration. For the manual pulse generator settings, the maximum frequency of MPG and output pulse ratio are required here. And home settings can choose over home search and home speed settings. 6 typical scenarios are introduced to demonstrate the automatic home searching. Next one is the axis status display, the motion information for each axis, including the logic position counter, encoding position counter, current speed, and acceleration. Limit switch and homing signals indicate the status of limit switch and home related sensor. There are also some useful buttons such as reset the target card to the initial state for the reset button. Home button can start the auto home searching. Reverse direction, forward direction, and stop motion can be also set here. Next one is the interpolation dialog. You can set like linear and circular. There are 3 different acceleration modes and supported, like constant speed, T-curve, S-curve acceleration modes. This one is axis disposition settings. It can configure the axis that are related to interpolation operation. Parameters, arc mode. The arc mode indicates the direction of the circular interpolation, clockwise or counterclockwise in the circular motion. Finish point and center point settings is configured each finish point of the interpolation related axis and center point for the circular one. Position status will display the motion information for each axis, including a logic, position counter, encoded position counter, and current speed. So you also have the return button, can reset. The reset button can reset the target car to the initial state, and stop button for the stop the motion. The last one is the FRNet DIDO dialog. The SAN, which is the digital input status, can display the DI status of the target FRNet module. And RAN, which is digital output set, you can select the group address for the specific FRNet DO module and select the digital output to the DO module here. So reset button will reset the FRNet connection. Any questions so far?
If you have any questions, just type them into the chat box. Okay, I guess if there's no questions at this time, you can always contact us by email. Thanks for coming to our
DO module here. So reset button will reset the FRNet connection. Any questions so far?
If you have any questions, just type them into the chat box. Okay, I guess if there's no questions at this time, you can always contact us by email. Thanks for coming.